Hello, this video let's discuss all about the differential calculus. What are those basic formulas about differentiations? So when we say differential calculus, it is a branch of mathematics concerned with the determination, properties, and application of the derivatives and its differentials. Okay, so we have the basic formulas and examples we need to use for this topic. First is we have the algebraic functions, the derivative of constant. So later on, let's discuss the examples. And then this one is the chain rule, the derivative of constant, and then the derivative of two functions u and v, and then the derivative of the product u times v, and then the derivative of the square root of u, that is du over dx over to square root of u, and then the derivative of the fraction, that is u over v, that is b du over dx minus u dv over dx over the b square. So on with the logarithmic or exponential functions, that is the derivative of ln u, that is just du over dx over u, and then the derivative of the constant e raised to the power of u, that is just e raised to u ln e times du over dx, and then the derivative of e raised to u, that is equals to e raised to u du over dx. And then we have here the trigonometric functions. If we get the derivative of sine u, that is just cosine u and du over dx, and then the derivative of cosine u, that is negative sine u du over dx, the derivative of tan u, that is equals to secant squared u du over dx, and then the derivative of cotangent u, that is negative cosecant of u du over dx, and then the derivative of secant u is equals to secant u tangent u, then du over dx. Lastly is the derivative of cosecant u, that is negative cosecant u cotangent u du over dx. So that's basic formulas we need to understand what are those concepts behind. Present to you is the formulas. So we have one examples in order to understand these basic formulas. Okay, so let's start with the algebraic functions. Formula number 1, that is the d over dx quantity c is equals to 0. We have a problem that get the derivative of 2 with respect to dx, and then get the derivative of negative 2 with respect to dx. So we have a formula. If we have this, if we need to get the derivative of the constant, c here is the constant. So whatever the value is constant, the derivative is equals to 0. So therefore, if we get the derivative of this value 2, so the answer is simply 0. And then together with this problem number letter B, the derivative of negative 2 with respect to dx, the answer is 0. So that's the concept for the formula number 1. The derivative of constant is equals to 0. And the second formula, that is the derivative of u raised to n with respect to dx is equals to n times u, and then raised to n minus 1 du over dx. So our in here is the exponent, our u is the variable or base. We have an example that is get the derivative of this x with respect to dx. So our formula, our in here is automatic 1. Okay, so or we can say that is x raised to n. Okay, to get the derivative, that is, or to say derivative of x raised to 1. Okay, so from the formula, okay, our in here is 1. That is just bring down this exponent 1 to its base, so that is 1, and then x, and then the exponent, that's 1 minus 1, that's 1 minus 1. Okay, so we have 1 times x raised to 0, and then we have a rule that any number raised to 0 is equals to 1. So our answer will be 1. And then from the problem number 2, get the derivative of 2x squared with respect to dx. Again, to do that, isolate the isolate this constant 2 times the derivative of this variable x squared. Again, and then from the formula, that is 2 times, okay, this exponent, our in here is equals to 2, so that is 2x n minus 1, that is 2 minus 1, okay, is equals to, we have 2 times 2, that is 4, and then x, so 2 minus 1, that is just 1, or our answer is simply 4x. Okay, so this is our answer from the example letter B. Okay, this formula number 2, other term for this is the chain rule. Okay, so let's proceed to the formula number 3. From this formula, the derivative of z times u with respect to dx is equals to c du over dx. Again, from this formula, this c is the constant, Okay, RU is the variable. Okay, so if we get the derivative, just isolate the constant, then get the derivative of this du over dx. We have a example. Get the derivative of 2x with respect to dx. Again, to do this, again RC here is 2, and then RU here is x. Okay, so C, isolate the constant, that is 2. Then get the derivative of this variable x. Okay, so that is just 2. And then again, from the chain rule, that is x x raised to 1. No. To get the derivative, we have bring down the exponent 1, and then multiply by x, then 1 minus 1. So any number raised to 0 is equals to 1, so this will become 1. So 2 times 1 is just 2. So this will be our final answer. So for the letter B example, get the derivative of negative 3x squared with respect to dx. To do this, we isolate the constant negative 3, and then get the derivative of this variable x squared. Okay, so that is just negative 3 times, bring down the exponent to x, then subtract 2 minus 1, so that is just negative 6 x 2 minus 1, that is just 1. So our answer here is this one, negative 6x, and then from the number 1, that is 2. So let's proceed to the formula number 4. Okay, this formula, the derivative of u plus b with respect to dx, that is just du over dx plus the derivative of db over dx. We have examples. Get the derivative of 3 plus 5x with respect to dx. So here is the solution. Again, get the derivative of each. So we have the derivative of 3, that is d over dx, then 3, and then plus, okay, isolate the constant 5, then get the derivative of this variable x. Okay, so we have the derivative of this 3, so this is equals to 0. Okay, then plus, we have 5. The derivative of x is just equals to 1, so therefore our answer is simply 5. Okay, so let's omit this one. So therefore the answer for the problem, the derivative of 3 plus 5x is equals to, we have 5. For the next problem, get the derivative of 2x plus x squared with respect to dx. So here's our solution. Okay, get the derivative of individual. Isolate this constant 2, then get the derivative of this variable x. Okay, so plus this one, d over dx, then get the derivative of x squared. Okay, so 2x plus x squared. Next is we have 2. The derivative of x is just equals to 1 plus the derivative of x squared, that is just 2x, and then exponent 2 minus 1, that is 2 plus we have 2x. So that is the answer for problem number 2. Okay, so that is the example for the get the derivative of individual u plus b. Okay, so let's go to formula number 5. This formula, this is for the product of derivative u and b, that is just u, then derivative of db over dx, plus v, and then du over dx. We have a problem. Get the derivative of x times y with respect to dx. So our u here is x, our v here is, we have y. So from the formula, that is u, and then db over dx plus b, du over dx. So from that, our u here is x. Get the derivative of y, it's just and then plus our b here is y, then get the derivative of x. Okay, so from that we have just bring down this x. Okay, so the derivative of y with respect to dx, that is just 1 or y prime, plus the derivative of x, so that is just 1. So we have only the y. So therefore this is the answer for the derivative of product of x and y. And then from this problem, letter b, our u here is x squared, our b here is y squared. So from the formula, we have u db over dx plus v du over dx, and then our u here is the x squared, this one, so get the derivative of this y squared, is d over dx, then we have y squared plus our v here is this one, it's y squared, and they get the derivative of this x squared. Okay, so from that, we have x squared, the derivative of y squared with respect to x, that is just 2y, that is bring down the 2, exponent 2, and then that is, they cancel out, no, exponent 2 minus 1, is 2 minus 1 here, so that's just 1. 2y times y prime, plus we have y squared, the derivative of x squared is 2x. Okay, so we have, if we simplify this one, we have 2x squared y, and then y prime, plus we have 2x, and then y squared. So that is our final answer. Okay, so that's for the product of derivative. If we have u times b, that is just u db plus b du. Okay, let's proceed to formula number 6. Okay, this one, get the derivative of square root of u with respect to dx. So the formula is just get the derivative of this variable u, that's du over dx plus over 2 square root of u. And then we have an example, get the derivative of 2 square root of x. So from here, our u is 2x. To get the derivative, okay, so that is just 2. Okay, so to proceed, we have this formula, du over dx over, we have 2 square root of u. So we have our du over dx, that is 2, and then over, we have 2 square root of u. Our u here is this one, that's 2x. So cancel this constant 2. We have remaining 1 over square root of 2x. So that is the answer to the get the derivative of square root of 2x. So from here, we have problem letter B. Get the derivative of square root of 3x. So again, from that, our u is equals to this one, 3x. To get the derivative, du, that is just 3. So from the formula, we have du over dx. Actually, this is 3 du is equals to 3 dx. Okay, that is why if we get du over dx, the answer is 3. And then from here, if we get du over dx, the answer is 2. Okay, so from that, the du over dx is equals to 3, and then we have 2 square root of u. Our u here is 3x. So this is the final answer. That is for the square root of how to get the derivative of the square root. Then let's proceed to problem number 7. We have here the get the derivative of fraction. If we get the derivative of u over v with respect to dx, that is just v du over dx minus u db over dx over b squared. We have a problem. Get the derivative of x squared over y. So our u here is equals to x squared. To get the derivative, that is just du equals to 2x dx. So our du over dx is equals to 2x. So this is our u, this is our v. And then from the second one, our v is equals to y. This one is y. To get the derivative, db is just equals to 1 y prime, and then dy, okay, or just simply y prime. And then to be clear that this y prime, this is just equals to or the same as dy over dx. Okay, so let's continue. From the formula, we have b du over dx. So our v here is, we have y, and then du over dx, we have 2x minus our u here is x squared, and then our db over dx, this is just y prime, okay, all over b squared, that is y squared. And then to continue, we have we need to simplify this. That is 2xy minus this one, that is x squared y prime, all over this one, that is y squared. So this is the answer for get the derivative of x squared over y. So this is the answer. Okay, so for problem number problem letter B, we have get the derivative of 1 over x squared with respect to x. Again, our u here is 1. This is our u. And then this is our v, okay, this one. So again, our u is equals to 1. So get the derivative with respect to x, that is 0, okay, with respect to x. And then our v is x squared. To get the derivative, that is db is equals to, we have 2x dx. So our db over dx is equals to 2x. Okay, from that, let's substitute to our formula. We have v, our v is x squared and then b du over dx, but our du over dx is equals to, we have this 0, okay, minus u. Our u is just 1, multiply by db over dx, that is just 2x, all over x squared. So x squared is to 2, so that is x raised to 4. This will be cancelled out. Okay, so this is negative 2x over x raised to 4. Then cancel out 1x. So we have negative 2 over x. That is the answer for get the derivative of 1 over x squared. So that is our answer. So that's how you get the derivative of the fraction. Okay, so let's continue to the next formula, that will be exponential and logarithmic functions. Okay, from this one, the logarithmic exponential, if we get the derivative of ln u with respect to dx, that is just d over dx over just simply u. We have here a problem. Get the derivative of ln x with respect to dx. From that, our u here is x. Okay, so to get the derivative of du, that is just 1 dx, or d over dx just equals to 1. And then from that, okay, from the formula, d over dx is just 1 over u. Our u here is x, so that is the answer. If we get the derivative of ln of x. Okay. Next, from the problem number 2, get the derivative of ln of x squared. Okay, from that, our u is equals to x squared. This is our u. Then to get the derivative, that is just 2x dx, or d over dx is just equals to 2x. From that, substitute to the formula, our d over dx, that is just 2x over, we have u. Okay, our u is x squared. So from that, we have x squared, and then cancel out x, variable x. So we have that's 2 over x. Okay, so that will be the answer to get the derivative of ln of x squared. Okay, so that's how you're going to get the derivative of the logarithm of variable. Okay, next, to proceed to the formula number 9. Okay, this formula, if we get the derivative of e raised to u with respect to dx, so our e here is constant. Okay, and then our u is the exponent. Okay, so we have to get the derivative of this, we have e raised to u ln of e times du over dx. Okay, from this problem, get the derivative of 2x with respect to dx. So ru is equals to x. To get the derivative of u with respect to x, it's just 1, and then dx, so our du over dx is equals to 1. And then from the formula, we have e raised to u, that is just the same with this problem. 2 raised to x, okay. ln of a, our e here is this one, it's 2. Okay, that is just ln of 2. And then du over dx, but our du over dx is just 1. So we have 2 raised to x, we have ln of 2. Okay, so that is the answer for get the derivative of 2 raised to x. Okay, from the second problem, we get the derivative of 2 raised to x squared with respect to dx. So from that, ru is equals to this one, x squared. So to get the derivative with respect to x, that is 2x dx. So our du over dx is equals to 2x. Okay, from that, we have formula that is e raised to u, the same with this one, 2 raised to x squared, and then ln of e. Okay, our e here is 2, this one is ln of 2 times du over dx, that is 2x. So therefore, our answer will be 2x times 2 raised to x squared and ln of 2. Okay, so or we can simplify that. We have 2, the same base, so that is x plus x squared. We have ln of 2, so that is the derivative of d over dx that's 2 raised to exponent of x squared. Okay, so this is the answer to the problem. Okay, so next formula we have from number 10, we have get the derivative of e raised to u with respect to dx, so that is just a raised to u times du over dx. Okay, for problem number 1, we have get the derivative of e raised to x with respect to dx. So from that, our u here is x. Okay, to get the derivative, that is just 1, or simply okay, that is just 1 dx. So our d over dx is equals to 1. Okay, from the formula a raised to u, that is e raised to x, d over dx is just 1. So our answer will be e raised to x. So that is the answer for to get the derivative of e raised to x with respect to dx. Okay, for problem number 2, get the derivative of e raised to 2x squared over dx. So from that, our u is equals to 2x squared. So to get the derivative, that is just 4x and then dx. So therefore, d over dx will be 4x. So from that, from the formula, we have e raised to u. Okay, so that is just e raised to 2x squared multiplied by du over dx. We have 4x. So simply our answer will be 4x e raised to 2x squared. Okay, so that will be the answer, okay, to the problem for get the derivative of e raised to 2x squared. Okay, so that's how you're going to solve for the exponential of logarithm. Next is we have this trigonometric derivatives. So we have here the trigonometric functions. So to get the derivative of sine u with respect to dx, that is just cosine of u. Then get the derivative of du over dx. We have a problem. Get the derivative of sine 2x with respect to dx. So from that, this is our sine, okay, u. So our u here is simply 2x. Okay, to get the derivative, that is just 2. The derivative of x is just 1, so that is just 2 dx. So our du over dx, that is just simply 2. Okay, from the formula, just substitute. We have cosine of u. Okay, our u is 2x. Then multiply the d over dx. It's just simply 2. So our answer will be 2 cosine of 2x. So that is the answer for, if we get the derivative of, we have sine 2x. Okay, from the second problem, get the derivative of sine 3x cubed with respect to dx. So from that, our u is this one, this 3x cubed. Okay, to get the derivative, we have du is equals to 3 times 3, that's 9. 3 minus 2, that's 3x squared. And then dx, or d over dx is just the same as 9 x squared. Okay, so from the formula, we have sine, we have cosine of u. Okay, so we have cosine of 3x cubed, and then multiply by du over dx, we have 9x squared. So our answer will be 9x squared cosine of, we have 3x cubed. Okay, to avoid confusion, this will be the angle of 3x cubed. Okay, so that is the answer for derivative of sine of 3x cubed with respect to dx. Okay, next is formula if we get the derivative for cosine of u. Okay, if we get the derivative for cosine of u with respect to dx, that is just negative sine of u, then multiply by du over dx. Okay, we have a problem. Get the derivative of cosine of x raised to 6 with respect to dx. Okay, from that, our u is equals to x raised to 6. To get the derivative will be du is equals to, we have 6 x raised to 5 and then dx. So du over dx is just equals to 6x raised to 5. Okay, from the formula, just get the negative sine of u and then multiply by du over dx, that is just 6x raised to 5. Okay, so our answer will be negative 6x raised to 5. We have sine of x raised to 6. Then that's the answer for if we get the derivative of cosine of x raised to 6. From the second problem, we have get the derivative of cosine of for x. Okay, so from this one, our u is equals to for x, if we get the derivative of u, that is just for dx, or our du over dx is equals to, we have 4. Okay, from the formula, we have just get the negative sine of u, sine of 4x. Okay, then multiply by du over dx, that is just 4. So our answer will be negative 4 sine of 4x. Okay, so that will be the answer for cosine of 4x. Okay, so next, let's have the other formula for the trigonometric functions. Okay, from these trigonometric functions, of course, of tangent u, that is just secant squared u, then du over dx. So that's the formula. We have a problem. Get the derivative of tangent x cubed. So our u here is just simply this one, this x cubed. Okay, and then get the derivative, that is just 3x squared dx, or du over dx is just 3x squared. Again, to proceed, formula secant squared u. Okay, our u is x cubed, and then multiply the du over dx, it's just 3x squared, or simply our answer will be 3x squared, and then secant squared, okay, x cubed. Okay, to avoid confusion, just enclosed by the quantity. Okay, so our answer for derivative of tangent of x cubed with respect to dx, that is just 3x squared, and then secant squared x, secant squared of the x cubed. Okay, next is we have the problem that is tangent of negative 4 over 3x. Okay, so from that, our u is negative 4 over 3x. Okay, our du that is just negative 4 over 3 dx. So our d over dx is equals to negative 4 over 3. Okay, from that we have a formula again is secant squared u, that is secant squared of negative 4 over 3x, and then d over dx is just negative 4 over 3. Okay, from that our answer will be negative 4 over 3 and then secant squared of negative 4 over 3 x. That is the answer for tangent negative 4 over 3 x. Okay, so that's how we're going to solve to get the derivative for tangent of any variable. Okay, let's proceed to the next formula. Okay, this one, if we get the derivative of cotangent of u with respect to dx, it's just negative cosecant squared u, then du over dx. Okay, from this problem, get the derivative of cotangent of x with respect to dx. Okay, from that, our u is equals to 8x. So our du over dx is equals to, we have 8. Okay, from the formula, we have negative cosecant squared u. Okay, our u is 8x. And then d over dx, that is just 8. So our answer will be negative 8, then cosecant squared of 8x. Okay, so that's the answer for cotangent of 8x. Okay, so next is get the derivative of cotangent of this one, cotangent of 5x. Okay, so from that, our u is 5x. Okay, so d over dx just simply 5. Okay, so and then from the formula we have negative cosecant squared. So negative cosecant squared of our u is 5x multiplied by d over dx, that is just 5. So our answer will be negative 5 cosecant squared of, we have 5x. So that is the answer for derivative of cotangent of 5x. Okay, from the next formula, okay, so that's how you're going to solve for the, if you get the derivative of cotangent of any variable. Okay, from this one, get the derivative of secant of u with respect to dx. That is just secant of u, tangent u, and then d over dx. Okay, so from here, get the derivative of secant of 2x with respect to dx. So from that, our u is equals to 2x, so to get the derivative of u with respect to x, that is just simply 2. Okay, from the formula, that is secant of u, tangent u, that is secant of 2x, and then tangent of 2x multiplied by d over dx, that's 2. Or our answer will be 2 secant of 2x and then tangent of 2x. To avoid confusion, just get the place the quantity. Okay, so that is the answer for derivative of dx for secant of 2x. Okay, so next is we need to get the derivative of secant of ln of x. Okay, from this problem, it is understood that RU is this one, ln x. Okay, so to get the derivative of du of this ln x, if we get the du, okay, so RU here again is x, so just get the derivative of okay, that's the same with from the previous formula. Just get the derivative of dx of x is over x. Okay, so from that, du is just 1. The derivative of x is just 1, so that's 1 over x dx, or du over x is just 1 over x. Okay. Okay, so from that, let's substitute from the formula. We have secant of u, that's secant of ln x. Okay, and then tangent of ln x, and then multiply by this du over dx, that is just 1 over x. Okay, so our answer will be secant of ln x times tangent of ln x, that is over x. That's the answer for d over dx of secant of ln of x. Okay, so that's how you're going to solve if you get the derivative of secant of any other variable. Okay, let's have for the last trigonometric functions. Okay, from here, if you get the derivative of cosecant of u with respect to dx, it's just negative cosecant of u, cotangent of u, and then du over dx. Okay, so we have a problem. Get the derivative of cosecant of 7x with respect to dx. So from that, RU is equals to 7x to get the derivative of u. With respect to dx, that is just 7. Okay, from the formula, we have cosecant of u, so it's negative cosecant of 7x, and then cotangent of u is cotangent of 7x, and then du over dx, that is just 7, or simply our answer will be negative 7 and then cosecant of 7x and then cotangent of 7x. Okay, so that is the answer for if we get the derivative of cosecant of 7x. Okay, so from the last problem, we have get the derivative of cosecant 3x. Okay, so from that, our u is 3x. Okay, to get the derivative of du with respect to the x, that is just simply 3. Okay, so after that, in the formula, we have negative cosecant of 3x and then cotangent of 3x, then multiply by du over dx, that is just 3. Okay, so from that, our answer will be negative 3 cosecant of 3x cotangent of 3x. Okay, so that is the answer for get the derivative of cosecant of 3x. Okay, so that's how you're going to solve for the various problems involving algebraic, exponential, logarithmic, or either trigonometric. Okay, so that's the basic or fundamentals if you solve the differential calculus. So to continue, we have other formulas like inverse trigonometric or hyperbolic functions. So that will be for the next session. So hope you understand our video for today, all about the basic fundamentals or basic derivatives in differential calculus. Then we have practice problems in order to understand the basic concepts and the formula. Okay, thank you.